Good morning, everyone. First of all, I would like to express our gratitude to our teacher, Mr. Kishpir Babu Suwedi sir, for letting us this opportunity to provide our knowledge in front of everyone. Before we move to our topic, first of all, I should begin with our formal introduction. My name is Samir Roka.
It's me, Prameswar. It's me as Tripri.
Now we shall move into our topic.
Today I am going to teach you vector. Vector is anything that has magnitude and direction and types of vector. If two vectors are in same direction, then they are called like vectors. And if two vectors are in different direction, they are called unlike vectors. For the equal vectors, if two vectors have equal magnitude and equal direction, they are called equal vectors. Null vector. If a vector have same starting and if a vector have same starting and ending point, then this is called null vector. If a vector has magnitude 1, then it is called unit vector. And for the co-initial vector, if there is a vector OA and OB, as there is same starting point O, so it is called co-initial vector. If two vectors are in same line or same parallel support, then it is called collinear vector. For the coplanar vector, if suppose this is a plane and there is two vectors A and B, this is in the same plane. But if I add one vector C, this is not in the same plane. So to be coplanar, vectors should be in the same plane. So the property of the one property of coplanar vector is that the if there is three coplanar vector, then one coplanar vector can be expressed as a linear combination of other two vectors. So thank you.
Now we shall move into MCQs. MCQs are just 1 marks question, so it determines your grade. Either you get A plus, A or B plus. So I shall make you properly understand the MCQ question. First of all, we have question: if A vector equals to K modulus of in A vector, then K is equals to you know that the A cap represents the A vector by modulus of A vector. Now using that we can write A vector is equals to K of A vector by modulus of A vector. You can just cause this and modulus of A vector equals to A vector, which is our option number C. Now we have another question: if AB vector equals to 2I vector plus J vector minus 3K vector, and the coordinates of A vector are 1, 2 and minus 1, then the coordinates of B are so for this you can just construct a triangle A B vector and consider the O point vector. Then we have this is A vector, this is B vector. Now consider this as C vector. Now for this AD represents A, this can be written as AO plus OB vector, and AO vector can be written as minus OA vector plus OB vector. Or our own B, we can write B vector is equals to 2I vector plus J vector minus 3K vector plus I vector plus J vector minus 3 vector. This is our BI vector plus J vector minus 4Q vector, which is our option number C. For our another question we have: if A vector represents 3I vector plus 4J vector minus 5K vector, and B vector equals to 6I vector minus 8J vector plus 10K vector, and we have to find the ratio of modulus of A vector by modulus of B vector. Now for this we can just do 6 whole square plus minus 8 whole square plus 10 whole square divided by 3 whole square plus 4 whole square plus minus 5 whole square. It will be the answer will be 2 and which is our option number B. Now we have same question for another type. If A vector equals to 2I vector plus J vector minus 8A vector and B vector equals to B vector A vector minus 4A vector, then what is magnitude of A vector plus B vector? Before finding that, we have to find the sum of A vector plus B vector, which will be now we can find the magnitude. This is our option number 8. Moving on to next question, we have to find the distance between two position vectors. Consider this as point A and point B. Just to vector minus B vector, and we have point B over I vector minus J vector. Now we have to find the distance between them. For distance we have formula x2 minus x1 whole square by y2 minus y1 whole square plus z2 minus z1 whole square. We can use the same formula for that. 4 minus 2 whole square plus minus 3 minus 3 whole square plus minus 4 plus 7 whole square. It will be 2 square plus 36 plus 9. It will be under root 49, which will give us answer 7, which is our option number D. Now we have another question. The vector of magnitude 7 in the direction of A vector equals to 3I vector minus 2J vector plus 6K vector is. For this we can consider our K variable with magnitude 7. Now the value of A vector is given. K is equals to 49, which gives us A is equals to 1, K is equals to plus minus 1. This signifies the given vector is the vector which is in the direction of A vector. Now I will do one last question, which is our question number 14. If A vector and B vector are the position of vector A and B respectively, the position vector of C on AB produce such as AC equals to AB. We are given condition AC equals to 3 times AB. You know AC can be written as AC minus OA vector. minus AB times AB can be written as OB vector minus OA vector. OC minus OA times OB vector minus OA vector. So OC which is our option number D. Now I would like to the market.
So alright, so I have decided to work on problem 8C because I think that most people find this problem particularly difficult. So we are asked to prove that three vectors are coplanar, but let's study its property at first. Suppose this is a plane, alright, so this is a plane, and whatever I draw on this plane, it will become coplanar. So if I draw any three vectors, it will automatically become coplanar. So what's the idea behind the three coplanar vectors? Assume I have a vector that's vector A, and we have another vector which is vector B, and I have a third vector that's vector C. So my claim is that I can write the third vector C as a linear combination of the other two vectors. This is my claim, and I will prove it to you. So for that I'll just reverse the direction of A, and this vector will become x times vector A. Obviously x will be negative because the direction of this vector and this vector is just opposite. So I can write this as in this form, and similarly I can take a unit vector. I can take another vector which is y times vector B along this, and I can shift vectors. So I'll shift this vector right over here, and this will become x times vector A, this will become y times vector B. So from the triangle law of vector addition, I can simply state that vector C is equals to x times vector A plus y times vector B. So I have proven you that any three coplanar vectors can be written as a linear combination of the other two vectors. So using this concept, we are gonna solve the problem. Alright. So what we have been given is we have a vector which is equals to A minus 3B plus 5C, and similarly R2 vector is gonna be equals to A minus 2B plus 3C, and R3 vector is equals to minus 2A plus 3B minus 4C. So alright, we are asked to prove that these three vectors are coplanar. So we're just going to assume that yes, indeed these three vectors are coplanar. So using our previously stated statement, we can write R3 vector is equals to x times R1 vector plus y times R2 vector. All we need to do is find x and y so that this relation is valid. So let me just write R3 vector over here. Minus 2A plus 3B minus 4C. So all I have done is I have regrouped this thing into vector in the form of vector A, vector B, and vector C. So I can just compare the coefficients. So I'll obtain x plus y equals to negative 2, minus 3x minus 2y will be equals to 3, and simply 5x plus 3y will be equals to negative 4. So solving these two equations, you will get x equals to 1 and y equals to negative 3. Now let me put these two values into this equation. So I'll get 5 times 1 plus 3 times minus 3, which will be equals to 5 minus 9 equals to negative 4, which is in fact the answer. So R3 vector can be written as x, which is simply R1 vector, and negative 3 R2 vector. So if we can write it in this form, then we have proved that it is indeed coplanar vector. And thank you.